Check, check. Do we have, it sounds even like there's a little bit of feedback, which is neat. Confirm devices. So welcome to the PathAware Networking Research Group. This is IETF 123. This is July 2025. We are in Madrid. If these are not correct, then you are in the wrong time and space, and should find the time and space you're looking for. Welcome to PANRG. We have a relatively quick agenda today, but I'm going to go ahead and start with the note well. This is actually, we usually aren't on Monday, so this might be the first time some of the people in this room have seen this. So the IETF follows the Intellectual Property Rights disclosure rules for the IETF. If you are, everything that you say during this meeting or on the mailing list is a contribution to the IETF, you should be aware of all of the rules on these slides. Actually, we should change these slides for the next ones. You should also be aware that there is a code of conduct for the IETF and anti-harassment procedures for the IETF. In addition, there is now a separate code of conduct for the IRTF. You can use the search engine of your choice to find that and make yourself familiar with it. So if you are in person, please scan the QR code in the microphone or go to Meet Echo via a mobile device to the on-site tool. This is necessary for joining the Meet Echo queue. It also allows us to count how many people are in the meeting for the blue sheets, which are neither sheets nor blue anymore. If you are on Meet Echo, please keep audio and video off unless you're speaking. To speak, you can join the queue and we will enable you. For speakers, actually, we're going to manage both of these for you, so you can avoid or you can ignore those. That directive. Wanted minutes taker. Hi, Dirk. How's it going? It's good to see you. Huh? Yeah, please do. Yep. Good. So, quick agenda today. You are here. Introduction agenda. Note well. Tilman Seshka will be talking about network awareness acknowledgements in quick. Followed by a quick update on the state of the Scion drafts through the ISE, and then we will have balance of time for an open mic. So with that, Tilman, come up. There you go. Yeah, that one.
Good morning.
Might want to adjust, yeah.
Good morning. My name is Tilman Seshka. I'm from ETH Zurich, and I'm here. I would like to propose a new internet draft with guidelines for running a quick multipath extension over Scion. So these are guidelines for implementations of libraries, so not for end users or applications or other parties. So I'm just going to give a brief overview and then talk about benefits and challenges of running quick multipath over Scion. So quick multipath, the multipath extension for quick, I think it's currently iteration 15, and as far as I can tell, it's pretty close to being finalized. What we're interested here in this context is the explicit path management of multiple paths, or the ability to create paths and remove paths explicitly. Also the path ID, which goes beyond the 4-tuple, which in turn allows us to have multiple paths per 4-tuple. For Scion is a path-aware networking technology for interdomain routing. There are currently 2 drafts, one for the control plane and one for the data plane. And there are 2 things we are mainly interested in this context. That's the Scion network address. It consists of ISD AS number, IP address, and port. So the ISD AS number is basically the AS number where the end host is located, and ISD number is like a grouping number for ASs. So the second thing we are interested in is sign paths. So paths are like a series of ASs, of interfaces and links with metadata. So if you look at the example, it's like on the left we have a client that is located in AS number 3, and then there's an AS in the middle, and then on the right side we have a server located in AS2. And for all the links and ASs we get MTU information, latency information, bandwidth information, and the hop count internal to the ASs. The lifetime of a path is usually hours or days, and then the path expires, so it's not valid anymore. And also important in this context is that we often may have hundreds of paths between two endpoints. So could we just run quick multipath over sign? And the answer is yes, we don't actually need to do anything, we could just run it, but we would miss out on some benefits, and we would also run into some security problems. So technically it works, but you should only do that in a safe environment. So first look at the benefits. We have obviously path metadata and the ability to explicitly select paths. For example, that allows us to select two paths that are completely disjoint. One would be the main path and the other one would be the backup path. And then if the main path fails for some reason, the likelihood that the backup path is also affected is very low. Another thing we could do is, use the bandwidth and latency metadata that comes with the path for initial selection, because remember, we have a lot of paths potentially. Another thing we can do is avoid untrusted ASs. Untrusted also just means in this context, having a history of poor quality of service, for example. Specifically for congestion control, what we can do is we can look at the path and detect where these paths overlap, and then either avoid overlapping paths, or if we cannot avoid it, we can look at the segments or the links where they overlap and choose it in a way where we know that the link is unlikely to be a bottleneck because, for example, it has a very high bandwidth or something. That in turn allows us to simplify congestion control, so we can run congestion control separately on each path, and we don't need to really look up how it works on the other path. For RTT estimation, we can use the latency metadata for initial path selection, again, because we may have a lot of paths. And then we can, basically, if we don't have a latency critical application, we can just skip RTT estimation and use like the metadata. The thing is, the metadata may be a bit outdated. The metadata that comes, latency metadata that comes with the path, may be hours or days old, but I think usually you can argue that it's not going to be orders of magnitude different from what you have like a few hours later. Another thing we can do with RTT estimation is, because we have really explicit path selection and path knowledge, we can ensure that the forward and backward probe exactly use the exactly same path. So that's also beneficial for RTT estimation. And then we have MTU discovery, and again, it's a bit similar. We get the MTU data, and we can pre-select paths and rule out paths that have a too low MTU. And then we could still run MTU discovery, obviously, if you want. So in summary, for the benefits, the guidelines is trivially just look at the topology and metadata to simplify probing and other algorithms. Then second, do not probe all paths, because there could be too many, and that would be almost a denial of service attack if you do that. Then on the server side, at least, we can simplify RTT by always answering on the same path. We should also answer on the same path because we want to respect the client's choice. The client may have chosen a path for a reason, including security reasons. So I think it's a good idea to respect that if possible. And related, in the quick RFC, it already says like the client is responsible for initiating migrations, which can be interpreted as basically new paths. Okay, let's look at the challenges. That's mainly three, related to network address, to path identity, and path lifecycle. So for the network address, on the top you see like two sign network addresses. In the front, the ISDAS number, and then IP and port. And what you can see here is that they only differ in the last digit of the AS numbers. So the IP address and the port is the same for two different end hosts. So the two-tuple of port and IP and port is not enough to uniquely identify an end host. And that's, of course, critical for path validation, because usually if the end host changes, we want to trigger path validation. And that means we need to actually look at the ISDAS number. So we have a three-tuple that we have to look at. There are different ways to solve that. The cleanest way is obviously to adjust all implementations of quick multipath to actually look at the three-tuple, but that's yeah, obviously a lot of work. So what we also have seen in Cyan libraries is that they do IP port mangling. So they mangle the AS code into the IP and port, which ensures that if the AS number changes, also the port and IP changes, which in turn triggers path validation. But yeah, obviously that can have unintended implications on application level. For example, if the application expects there to be a certain IP address or port. Path ID is similar. Just to give a bit background, Cyan libraries may just try to look at like a normal UDP socket. So what they do, if you just give them an IP address, they will internally look up path, select a path, and then use that path. And the path may then, yeah, if the path has a problem, like it breaks and reports a problem, or it expires, the library will just update the path. And what should happen here, if the path changes, we should reset the congestion control and ITT algorithms. But here we can see that just observing even the network address, including ISDAS, is not sufficient, because the path may just change somewhere in between and the endpoints. So the guideline here is that we should ensure that the path changes still reset the congestion control and ITT estimation. And one way to kind of ensure that is that the Cyan layer should disable this automatic path updates if the path breaks or expires. At least when it's using quick multipath, because in other scenarios, this automatic update can actually be quite useful. And then if the path breaks, we let the quick layer or the application layer find a new path. And finally, the path lifecycle. So Cyan libraries may maintain a mapping from path ID to network address, or from the mangled IP port to an unmangled address. And the problem here is really how to maintain the lifecycle. It's easy to detect a new path for a library, but it's difficult to detect a path abandon, a path close, or just a packet that is rejected because it comes from an attacker or something and is invalid. So basically the guideline here is to, on the server side at least, try to not maintain any state, and instead let the quick multipath layer or application layer manage path. Unfortunately, that's not always possible. So for example, you can imagine a proxy that on one end understands Cyan, and on the other side of the proxy, there's just some servers that are connected via normal IP. In that case, the server has to maintain state. So yeah, we have to see how that can be solved. So in summary, when the network address changes, we need to trigger path validation, just to make sure this is quick path validation, not PANRG or PAN path validation, which is a different thing. When the path changes, we should trigger CC or RTT estimation reset. I don't think we must do it here, because even in current internet, sometimes the path may change and the end hosts may never learn of it. So I think the algorithms are quite resilient actually to having a path change. Then for the server, we should try to avoid state. It's also the security implications, because it kind of exposes you to memory exhaustion attacks or similar things. And finally, the Cyan layer should not upgrade broken or explicit paths. Yeah, and that's already most of the things that are in the draft. So now I have some questions. For example, we were thinking, is it a good idea to make this draft only about Cyan, or should we extend it to PANs in general? That may be more interesting, because I think there are many common points with other networking technologies. There are also security considerations, and I think here the problem is more that they can be very specific. So that's more an argument for having it only about cyan, because otherwise you will have tons of security considerations for different technologies. And if you actually make it about all or many PANs, then of how many PANs do we need to cover in order to be complete? Yeah, that's one question I don't really know the answer to. Yeah, also I'm happy to get any general feedback and suggestions or anything else. And if anyone would be willing to review the document, would be also very much appreciated. Thank you.
Questions from the floor?
Hello.
Oh, wait, Lucas is already in queue, so go ahead. Please go ahead and put yourself in the queue and meet Echo. You can put yourself in the queue and meet Echo. Lucas, go ahead.
Hi, Lucas Pardew, Cloudflare and co-chair of the Quick Working Group. I'm aware of Scion. I'm by no means an expert at all in it. And I've only been at PANRG a few times over the last few years, sorry, Chaz. But yeah, this is interesting work. As you say, the multipath quick extension has already been through one round of working group last call. The design is basically locked in. We're just ironing out some of the final few issues. I'm no expert in that either. I know enough to be, you know, we own an implementation of Quick, and we had to deal with some of the path awareness of the Quick library itself and how the applications integrate with that, even though we're not doing the full multipath extension. So this is kind of where my question is leading. Of Quick is kind of weird that it does have a notion of multipath just in RFC 9000, right? We have connection migration. Just so happens that those paths are not going to be used in parallel, but that you would transfer from one to the other. One of the examples is passive migration, where we have things like NATs. Brian can probably talk at great length about those. But in summary, you know, something happens within the network that changes the client's tuple, which triggers a migration event in the server to be able to assign that new packet from a different tuple to the correct quick connection and ensure that the migration events that you mentioned would happen. So this got me thinking, again, I haven't been able to read the draft or all of this stuff. How much of the guidance or the challenges that you're talking about just apply to Quick if it was to be operating over some other form of network that has different path awareness challenges? That's maybe too vague a question, but maybe we can abstract some of the stuff you have here or break it out to be kind of what you're suggesting. Maybe this is considerations for quick and path-aware networks that we didn't think about 5 years ago when we were targeting IP. I'd be happy to speak more about that off list. But also the other question was, have you spoken to the multipath quick authors about this and shared your ideas? Because they're way more familiar with it than I am. They might have some good feedback for you too.
Okay. Yeah, thanks. I haven't really spoken to anyone yet, so this might, it's a pretty new work. I do think a lot of that also applies to Quick, but I started looking at multipath Quick, so I haven't really tried to figure out what is actually not specific to multipath, but I guess quite a number of things.
Yeah, I'd recommend maybe posting an email to the Quick working group list. I'm looking around, I'm not seeing many folks from that thing, just because I think this is a really interesting piece of work. So, yeah.
Okay.
I would note, I don't think I see any of the multipath Quick authors in this room, but I have seen many of them at this meeting. So it might also be useful just to send to like the draft. You know, there's an email expansion for like the draft authors of a draft and say, hi, I've got this thing. Would you have any time to meet on the side? That actually would probably be a very good use of everyone's time.
Yeah.
Cool. Thank you very much.
Good. Thanks.
Did you figure it out? Okay. So if I may, I've taken a quick look at this. It seems like there's one sort of like large area, which is like, hey, if you're dealing with a different network architecture with Quick, you need to have some concrete mapping of that architecture's addressing scheme into how quick does pass, right? Like, so if I were thinking of like a multipath quick implementation, it would have like, you know, a quick connection sort of object, and then it would have underneath that quick path objects. And you'd need to basically say, you know, this is the way to map, you know, my addressing scheme to the path, right? Because that's a very important point with Scion is like in a lot of cases, your Scion, your IP address part of your Scion packet is probably going to be privately routed within that AS, right? Like, so realistically, I don't know how that's implemented in Scion Lab, but like those are not always publicly routable IP addresses inside the Scion side of the network. And then there's also the idea of like, hey, are these two IP addresses, like when they're not deployed like that, it's like, are these two IP addresses the same endpoint over different path? Like, there's nuance there to work out, and I think that like working out that nuance within the scope of the Scion multipath work makes it possible to do, you know, the idea of what is a path inside quick multipath a lot more rigorously, right, than if you're just looking at the single network architecture.
Okay, and then maybe this idea then to potentially propose an extension to the quick multipath
right.
kind of specifies that.
Yeah. Cool.
Sounds good.
As to, you know, putting my RFC 9217 author hat on, to your third question, I would say just doing it for Scion is great, right? Like, so for the number of network architectures you consider, there's basically only 3 numbers, 1, 2, or 0, 1, and greater than 1, right? Like, so just the Scion considerations, I think, are a very valuable contribution.
Okay. Yeah, thanks.
Other points, questions, etc. Yeah, okay, come on up. But do identify yourself so we for Nico,
okay.
the minutes taker.
Okay, Mingwei from Tsinghua University. So my question is about, you said when using quick multipath, the Scion layer should disable automatic path changes. Yeah. So my question is, will it decrease the performance or security of Scion?
The performance of security of Scion?
Of Scion. Decrease the performance or the security if Scion layer disabled the automatic path change.
I don't think it affects, so if I understand the question correctly, is whether disabling the automatic path change affects security or security performance. I don't think it does. It's just if a path change, I mean, the path change that should only be disabled if the path change ability is still in the application or in the quick layer. So someone will actually notice that the path is broken or error will be triggered, and a new path will then be created on a different level of the stack. So I don't think that's a security concern. Does that answer the question?
Okay, thank you.
Okay, thanks.
Going once, going twice. Thank you very much. And do definitely find the quick multipath folks in the hallway. I think that's,
yeah.
How long are you here?
Thursday evening.
Okay, cool. Yeah, you should be able to find some time. Thank you. PowerPoint karaoke. Featuring Nicholas. Good. Go.
All right. So now this is Nicola from Scion Association. I would like to give a very quick update regarding the Scion core spec. So these are documents that we discussed here quite a while ago, and then they are going through the ICE review process. So this happens a bit outside of the normal discussion, but as there's still discussions here, I'd like to try to feedback what is happening. So the core specification of Scion is in these 3 drafts that you see on top. So these are the core components, and then there are these additional topics as the one that Tilman presented. So what happened since last IETF? We actually got a really great control plane review from Alvaro. And we have been doing quite some work on the drafts. We still have some left. One of it concerns how these Scion numbers are represented, making it consistent with the drafts, and also updating the reference to the Scion number registry. So this is a function that is currently carried on by one of the vendors, Anapaya, and we are a Scion association taking this over. We also mandated the use of a certain number for unspecified interface ID, which is something used in the control plane. And we need this for interoperability between vendors. We have done also some general housekeeping in the drafts, including figures, needs, and normative language, and so on. We are actually not done yet, so parts of the updates are already in the latest draft versions that you see down here, but there are other topics where we are still thinking a little bit about the feedback received. One of it is the use of gRPC. So if you look at the draft, for example, there is a lot of protobuf definitions because the control plane in Scion uses a gRPC. And we are thinking, how do we list them properly in the draft? There's not so many documents that, that use protobuf. We are also thinking about the security considerations of using gRPC on top of weak HTTP3. We will also be adding these metadata extensions. These are not part of the core spec today, but we have seen that they are currently supported by all the implementations. They exist, so after discussion with the reviewers, we feel that these are worth to be included. This is also what the quick draft is using for example, getting latency and bandwidth and so on out of the Scion paths. We will be adding some clarifications on MTUs and how this MTU can be taken out of these Scion paths. I think that's it for now. We are still looking for reviewers. So if you're a path-aware networking enthusiast and are having a read at our drafts, we would be very happy if you drop us an email with some feedback, or if you want to do this within the ICE process, if you drop an email to the ICE editor, Elliot. That said, thank you. And if there's any questions about the spec, I'm around, or I'm here.
There. Any questions? Comments, remarks, claims, complaints about the cookies? That's Wednesday. All right. Thank you very much. With that, we will go to something we've never had time for, PANRG open mic. If anyone has any questions, things to introduce, et cetera, for the Path-Aware Networking Research Group, please come up. Seven seconds of uncomfortable silence complete. Thank you all very much. Enjoy the rest of your week, and we will see you in Montreal.